Hi there, are you tired of your old sauce being barbecue sauce? Well, boy, do we have the product for you. As we like to call it, the mathematical sauce. We have different kinds of flavoring.
So let's go on to 1.13. Alright, let's go over 1.13 using quadratic functions. A ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend pass. This year, the resort is considering a price increase. They estimate that for every $5 increase, they will sell 20 fewer holiday weekend passes. Part A, how much should they charge in order to maximize profit? I'm going to underline that word, maximize or maximum. Does that make sense? Okay, step one, how do we define our variables? Let's have X represent the number of $5 price increases. And then the function we're creating, this will represent the total amount of money generated. And remember, if you're ever getting like intimidated by the function notation, just change that to a y. It's really just x's and y's. Okay, so if I write an equation, p of x, and I say that p of x is equal to the price of each pass, which was $120. So a pass costs $120. But there is a $5 increase for the number of increases. And then the sold passes is going to be, well, I had 680 of them, but those will decrease 20 fewer, so subtracting 20 from the number that I holiday passes sold. I'm sorry, number of $5 increases. So my equation is just going to be p of x equals those two binomials or equations we have. And this is not in standard form. This is what we would call an almost x-intercept form. So I'm basically transforming x-intercept form into standard form. Basically means get rid of the parentheses. The book will teach you guys using FOIL. I'm going to show you guys something called the box method. Just organizes it. And we're going to do the same thing as FOIL. You're going to multiply, and then we're going to add or combine like terms. Okay? Okay, I'm going to get my calculator ready here on the side. So I have 120 times 680. That'll give me 81,600. 120 times negative 20. 120 times 120 times negative 20x is negative 240x. 5x times 680 is going to be 3400x. I missed a 0 on the top one. And then 5x times negative 20x is going to be negative 100x squared. So we'll just write this one is a constant. There's no other ones I have, no other x's in it, so that would just become 81,600. If I combine like terms with these two, if I add those together, I will get 1,000, positive 1,000x. So I'm done with those, and then subtract 100x squared. Okay, to put that into standard form, which means we put the x squareds, this is in something we call, pen's turned off. This is called ascending order. You notice the exponents 0, 1, and 2. So if you just flip it around, this is in now descending order. And descending order is what we need for standard form. Okay, so step number 3, find the axis of symmetry. So I'm going to write standard form above it. And I have A equals negative 100. B is 100. Excuse me, that was 1000x. So 1000. Remember, when you're finding your A, B's, and C's, they're just numbers. There's never an x or an x squared in there. So our formula is x equals negative b over 2a. So my b value is 1000. My a value is negative 100. So I'm going to have 1000 divided by negative 200. Feel free to use your calculator. 1000 divided by negative 200 is going to equal negative 5, and opposite of negative 5 is positive 5. Okay, now it says interpret the results. Okay, so before I do that, I'm going to jump over here and just draw a picture. Whoops, forgot my little trick. Hold it down and it's a straight line. Okay, in my graph, there's a couple of things I should notice. I first want to get in, maybe I didn't get an order pair yet, so let's do the function notation of interpret the results. Just take your x value and put it back into the function. Put it back into the function. So that would be this one right here. P of 5 now, so every x value is going to be 5. Feel free to use a calculator with the big numbers. No need to show off your math skills here. So I would get here 25 times 100 gives me negative 2500. This one's 5000, and this one you would get that number. So if we do all those numbers together, plus 2500, this is going to be your vertex. Okay, you don't necessarily need that number, so let's just give ourselves an idea. This is my y-intercept, which is your c value. The vertex, which was higher than that at 84,000. And this is what my graph looks like. And to solve, what they really wanted was that if you take the x value, how much should they charge in order to maximize their profit? Their profit formula stands for P, right? And that was this one. So let's go ahead and take x equals 5 and put it into that formula. Let me write it down here. So P of x equals 120 plus 5x. And we said we're going to put in this 5 here. And P of 5 equals 120 plus 5 times 5. So P of 5 equals 120 plus 25. So P of 5 equals 145. Let's write a sentence to help us understand what this means. Double boxes, that's my final answer. I want to give you a visual for the next part. The ski resort will make the most money with 5, that's what my X value was, price increases so they can charge, what was the Y amount? $145 for each holiday weekend pass. Okay, let's take a look and find the domain and range, and that's the reason why I drew the graph a little bit prematurely, but what values can I get for the X? Okay, because we're talking about profit, you can only start here to here. So X represents the number of price increases, and this represents over here money, right? 84,000. Okay, so you can't have negative. That's the reason why I don't have anything over there. X for nothing over there. Let's so to get that number, let's it's okay if you don't do this part. To help you explain why we don't have that number. But I'm going to put in that formula. Negative 100 x squared plus 1000 x plus 81,600. And the neat thing about a graphing calculator is I press graph. I can just keep pinching until I get, well, when's that? It's changing the scales for me, if that makes sense. And so what I want to find is the two X intercepts. And that number is 34. Okay, so that's going to be my domain. My domain is going to be 0 to 34. And again, you can't account for the negative side, the red side over here I'm going to draw. You can't have number of increases to be negative. Okay, range is, you know, there is coming from bottom to top, something, 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 and it stops right there at that red number line. So the red number was 84,100. And all of my graph is below that, so that would be less than or equal to 84,100. Now, I can't go below 0 because the amount of money generated cannot be negative, and the maximum amount of money generated is 84,100. All right, go ahead and try the questions below, and don't forget to skip one problem. Press play when you want to see some tips, or if you want me to see me do the same problem. Okay, a county park sells annual permits to its fishing lake. Last year, the county sold 480 fishing permits at $80. This year, the park is considering a price increase. They estimate that for each $4 increase, they will sell 16 fewer annual fishing permits. Define the variables and write a function to represent the situation. So X represents the number of $5 price increases. And the function P of X represents the total amount generated. So the money generated is the price per permit, which is $80, plus the $4 price increase, and the number of increases is X. And total passes is going to be the other one. So we have 480 fishing permits, and those will 16 fewer is minus 16x. Okay, so then I just need to multiply those two. So 80, doesn't matter how you put this on here. My calculator here. So 80 times 480 16 times 80 is going to give me negative 1280x. 1920x negative 64x squared. So negative 64x squared, subtract those, so 1920 minus 1280 gives me 640 plus 3800, 400. And that's my function. Okay, from there, all I need to do is solve for x. So a is negative 64. B is, sorry, not solve for x. We're trying to find the x value of the vertex, which is of the maximum. So 640, and then B or C is 38,400. So x equals negative b over 2a. My b value is 640. My a value is negative 64. So 640 divided by 128 gives me negative 5. So x equals also 5. So the county park needs to have 5 price increases So they should charge so let's put that number back in to our function here. We should put in x equals 5. So p times 5, 80 plus. So what's kind of nice is what? They're going to make to charge $100 per permit. Okay, what's our domain? Let's get a graph really quickly. It's gonna look just like the other graph. All right, let's punch it in. And here's a neat thing. Let's just say you should, another way of checking your answer, and then get out of here, is put in the multiplied one, and you should actually have the same graph, right? Equivalent functions. Just graph that, and you'll see that this number is, see, even that's kind of cool. Even stops it right at 0. So cool. 30, 0. So on your graph, we're just going from here to here, so that's 0 to 30. So x, you can buy anywhere between 30 for your domain, and then your range, if you put in 5 into the whole function, let's go back to our graph. You could just substitute in 5 into that number, graph, and here's 5. Even highlights it in red that 5, 40,000. So right there is 40,000. Whoops, erased my domain, sorry. So range is going to be starting at 0, because your profits, you don't only want to show your profits, to what number? 40,000. So my range is between 0 and 40,000. All right, let's go ahead and do number 12. 1.5 squared. And we get 3,645. Oh, I did it again. I know what I did wrong. Okay, that represents, if we did the graph, sorry, that value is at 1.5. This is 3,645, what we just saw. I forgot that we need to put this value into the profit one. So that would just be 30 minus 2 times 1.5, so 30 minus 3, so the answer is 27. They should charge $27 per candle to max the profits. And to figure out the domain, you can just punch that into your calculator. And let me prove to you why they are the same. I need to take a picture of this top one up here. And this is a way your calculator can actually check your algebraic work, which is okay, it's not cheating. Okay, Okay, let me put in the parentheses one. 30 minus 2x. The x is not times on the right. The ones in blue are the order of operations. X is a variable that's towards the second and alpha, the orange and light blue key. 120 plus 10x. Okay, and if I put in the one that we did multiplied through the box, so that would be the 3600 plus 60x minus 20x squared. And what I want to show before I press graph is that if there's two separate graphs, that means what I did are not the same. But if the graphs are the same, like you can only see one graph, that means those two expressions are actually equivalent. One has parentheses, which is the factored form, and the other one is called standard form. So let's go ahead and graph it. And we only see one parabola. Does that make sense? And the point of that is to show, again, that they are the same. Now, amazing enough, it actually looks like a depends how you. So if you put here, let's see. See, I'm trying to get the max there, and you have 1.5, and 3,645 is our total profit, and the number I wanted to find over here was our 0. When it means 0 is the y value 0 and your x is. Alright, what's most important is I've explained math. And we said it was like a 30, right? So that basically means this is 0, this is 30. And those are all the numbers we want for the domain, x-axis. So 0 to 30. Those are the amount of price decreases that we can do in this problem. Okay, what is our range? Well, again, I have to kind of start here on the y-axis. That's at 0. Because this is a real life problem. And it goes to the max, which I think was like 36. 45, I think. And that was question number 12.
Mr. Ing's class, we will greatly succeed. Intelligence we will breed and never ever cheat. And don't forget to show your work. Because when you get that 4.0, you'll have a huge smirk.